AI isn't science fiction anymore. It's solving real problems all around us today. From medicine to space exploration, breakthroughs in artificial intelligence are quietly reshaping how we live and work. Welcome. In this video, we'll count down 5 AI breakthroughs making a tangible impact right now. Each segment is grounded in peer-reviewed research, official company demos, or scientific data. No hype, just solid advances. You'll learn what each technology is, how it works in simple terms, and why it matters. We'll compare life before and after these AI tools, see real-world benefits in fields like medicine, industry, and science, and also note what each AI cannot do yet. By the end, you'll see that AI isn't a mystical future promise. It's a practical infrastructure technology already driving progress today.
1.
AlphaFold Protein Structure Prediction, DeepMind. AlphaFold is an artificial intelligence system from DeepMind that solved a 50-year-old grand challenge in biology, predicting how proteins fold into 3D shapes. Proteins are the machines of life, and their function is determined by shape. Traditionally, figuring out one protein structure took years of lab work and hundreds of thousands of dollars. In 2020, AlphaFold changed the game. It can predict a protein's 3D structure in minutes with remarkable accuracy. In DeepMind's official visualizations, we see AlphaFold's predicted models aligning almost perfectly with experimentally determined structures, highlighting its breakthrough precision. Before AlphaFold, scientists using X-ray crystallography, or cryo-EM, painstakingly solved only about 194,000 protein structures in decades. After AlphaFold, we suddenly have over 200 million protein structure predictions available in a public database. Already, scientists used AlphaFold data to develop potential new malaria vaccines and better understand Parkinson's disease. Drug discovery teams are analyzing previously unsolvable proteins for new targets. However, this technology cannot do everything yet. AlphaFold predicts static structures, but it cannot show how proteins move or interact in complex ways. Lab experiments are still needed to confirm functions and dynamics.
2.
GPT-4, large-scale reasoning and content generation, OpenAI. GPT-4 is a state-of-the-art large language model developed by OpenAI. In non-technical terms, it's an AI that was trained on huge amounts of text and images to learn patterns in language, logic, and knowledge. What makes GPT-4 a breakthrough is its ability to perform complex reasoning and generate human-like content on a practical scale. GPT-4 can draft essays, write computer code, explain jokes, or solve problems with clear step-by-step logic, often with human-level performance. OpenAI's own evaluations show GPT-4 scoring around the top 10% of test takers on a simulated lawyer's licensing exam. It's a dramatic leap considering its predecessor, GPT 3.5, was around the bottom 10%. In the official technical report charts, you can see GPT-4 outperforming not just older models, but even humans on various professional and academic benchmarks. Before GPT-4, AI chatbots often gave superficial or incorrect answers and struggled with complex queries. After GPT-4, we have AI that can draft business plans, debug software, or even help with medical questions in a far more reliable way. Companies use it to summarize documents. Doctors test GPT-4 as a medical assistant to suggest diagnoses. Educators use it to generate practice problems. Creators use it to brainstorm ideas. It's like having a versatile assistant that can understand and generate information on almost any topic. GPT-4 is not perfect and can still hallucinate incorrect facts or reasoning. It doesn't truly understand like a person, and sometimes its answers, while fluent, may be wrong or biased. It also has a limited context memory. It can only consider a certain amount of text at once. It cannot guarantee factual accuracy or common sense judgment in all cases, so human oversight remains crucial.
3.
Wayve, end-to-end AI driver for autonomous vehicles. London-based startup Wayve is pioneering a new approach to self-driving cars. Unlike traditional autonomous vehicles that rely on detailed 3D maps and hand-coded rules, Wayve's AI driver learns to drive almost like a human, by observing and practicing on real roads. The system uses end-to-end deep learning with inputs from cameras and a basic GPS route to output steering, acceleration, and braking commands. In 2019, Wayve became the first company to demonstrate a car driving autonomously on public roads using only machine learning. No laser sensors, no HD maps. In Wayve's published driving test footage, you can see their car navigating busy London streets with just a few cameras and a neural network making decisions, rather than an engineer pre-programming every detail. The before AI versus after AI contrast here is striking. Before, most self-driving projects needed years of manual coding and expensive sensors. Vehicles could only operate in cities that had been painstakingly mapped and under very controlled conditions. After Wayve's AI driver, the car learns from experience. Give it enough driving data, and it can adapt to new cities or even new vehicle types through transferable learning. In fact, by 2022, Wayve showed their single AI driver model could generalize from driving in London to driving in several other cities it had never seen, and even to different cars. This approach could make self-driving technology more scalable. Instead of mapping every road, an automaker could install Wayve's system, and the car would figure out the local environment. It's being tested in last-mile delivery vans in the UK, driving routes to deliver groceries. If successful, AI drivers might reduce traffic accidents by eliminating human error and improve delivery logistics by operating more efficiently and consistently. Wayve's AI is still in the testing phase. It cannot handle every bizarre edge case or difficult weather condition reliably yet, and it hasn't achieved full self-driving without human safety drivers. It's not level 5 autonomy yet, and like all current self-driving tech, it struggles with the unexpected. A scenario like a construction worker directing traffic or a blown-over sign.
4,
Artificial intelligence in radiology. Google Health's breast cancer screening. Artificial intelligence is now helping doctors detect diseases earlier. A prime example is Google Health's AI system for mammography, which is X-ray imaging used to screen for breast cancer. Reading mammograms is notoriously challenging. Tumors can be very subtle, and human radiologists might miss some cancers or mistakenly flag healthy tissue, leading to false alarms and unnecessary biopsies. Google developed a deep learning model that examines mammogram images and marks areas that might contain tumors. The AI was trained on thousands of de-identified mammograms from real patients, learning to recognize the complex patterns of breast tissue that correlate with cancer. It now serves as a second reader alongside doctors. Before AI, screening programs often required 2 radiologists to separately read each mammogram to reduce errors. And even then, small cancers could be missed, and many false positives caused anxiety and extra tests. After introducing the AI, studies show significant improvements. In a major evaluation, Google's algorithm reduced false positives by 5.7% in US test sets and by 1.2% in UK data. It also cut false negatives by 9.4% in the US and 2.7% in the UK. This means fewer people get wrongly called back for biopsies, and more real cancers are caught early when they're treatable. It's a glimpse of how AI might assist in diagnosing other diseases, like reading lung CT scans or spotting tumors on MRI. This AI is not a doctor. It cannot yet replace a human radiologist's judgment. It's an aid, not a standalone diagnostic. It may occasionally flag things that turn out benign, or miss an unusual cancer type outside its training. Also, thorough clinical trials are needed before wide-scale adoption to ensure the AI works on all populations and imaging machines. Radiologists must also adapt workflows to integrate the AI suggestions.
5,
Artificial intelligence in space science, exoplanet discovery with machine learning. Even astronomers have an AI assistant now. NASA and researchers worldwide are using AI to discover exoplanets, planets orbiting other stars. Space telescopes like Kepler and TESS collect enormous data sets, monitoring tens of thousands of stars for tiny dips in brightness that occur when a planet passes in front of a star, a transit. Separating real planet signals from noise, instrument glitches, star spots, etc., is a huge challenge. Astronomers have trained neural networks to sift through these light curves and identify the signature of potential planets. In 2019, a team led by Anne DiTillo used an AI called AstroNet K2, a deep learning algorithm adapted from Google Brain, to comb through data from Kepler's K2 mission. It discovered two new exoplanets, K2293b and K2294b, that human analysts had previously overlooked. These planets are super-Earths, larger than Earth but smaller than Neptune, orbiting stars over 1,200 light-years away. Essentially, the AI learned to recognize the shape of a genuine transit dip in brightness and distinguish it from other variability. The result, new worlds found in archival data without needing a person to check every possible transit by eye. Before AI, finding exoplanets was like looking for a needle in a haystack. Kepler, for instance, produced about 30,000 signals of interest that needed to be vetted. Teams of astronomers and citizen scientists spent years going through them, and some planets were confirmed only long after the data was taken. After AI, the process speeds up dramatically. Another study in 2021 applied an AI/ML system developed by the company Theta Ray to TESS data. It was trained on known Kepler planets, then ran through 10,000 plus TESS signal candidates and highlighted about 50 top contenders, leading to 3 new planet candidates that were then confirmed by follow-up analysis. AI isn't replacing astronomers. Think of it as a smart filter. It can still be fooled by unusual noise or astrophysical phenomena it wasn't trained on. Every candidate it finds needs human verification and usually additional observations. For example, using other telescopes to make sure it's a planet and not a binary star eclipse. So, while AI can pick out transit signals, the judgment of what it actually is, planet or something else, still relies on experts. It's quite poetic. We taught a computer to recognize the faint dimming of a starlight, and it's helping us find new Earths in the vastness of space. From deep oceans of data to outer space, these AI breakthroughs all share a common theme. AI has become a powerful enabling technology, quietly working in the background to augment human efforts. None of these advancements are about sentient robots or sci-fi tropes. They're about measurable improvements, higher accuracy, lower costs, faster results, achieved by machines learning patterns and assisting humans. AI is increasingly an infrastructure of modern life, much like electricity or the internet, driving progress in biology, transportation, healthcare, and exploration. Importantly, we've seen that each innovation comes with limitations, a reminder that AI is a tool, not magic. Used wisely, though, these tools are accelerating scientific discovery and solving practical problems that once seemed intractable.